Hi, everyone. Thanks for joining us today. Today's webinar, we have Dr. Prashant Gupta from Tata Power joining us, and we are discussing energy transition and opportunities in the energy sector. Thanks so much, Prashant, for joining us today. I'd love to begin this session by asking you to give us a quick background and introduction about yourself and your role at Tata Power.
Thank you, Aparna. Thank you for the introduction. As you rightly mentioned, I am basically a doctor by profession. So I have done my PhD in hydrogen generation. This was done from IITB Monash, which is a joint PhD from IIT Bombay and Monash University, Australia. So my background is I'm a chemical engineer and happened to join Tata Power for their carbon clean program in 2010. Since then, the profile has been to explore various clean technologies, evolving technologies in the energy domain in the power sector. And my role specifically is to see how we can bring these innovations within the ecosystem of Tata Power, pilot them, and at the same time mature them towards commercialization. So that's the brief profile I have.
Thanks for that quick introduction. That's really helpful in setting the tone. Since you have such a background in energy, I think today is going to be an exciting conversation. And speaking on behalf of all the engineers who are present and listening to us here today, um, I'd begin my questions around the energy sector soon. But before I do, anybody listening to us, please feel free to leave in your comments as questions. We may have a quick Q&A at the end of this session if time permits. And on behalf of those attendees, as engineers are looking for job opportunities, we are interested in Tata Power's role in India's ambitious renewable energy targets. So, how does Tata Power plan to contribute to the goal of achieving 450 gigawatt of renewable energy by 2030? And what engineering challenges are you addressing to make this a reality? That would be my starting point today.
Yeah, so in order to understand Tata Power's role, it also needs to be understood as to where Tata Power stands today. So, uh, historically, Tata Power has been a electricity generating company. It is in its 108th year right now. So, we started our operations way back in 1914. As per the vision of our founder, we wanted to provide clean, affordable, and green power. So, hydro was the first choice by which we started our generation. From hydro, we moved to thermal, be it coal, oil, or gas, and subsequently added solar and wind capacities. So, today, if I talk about my assets, we are basically having a generating capacity of close to 9 gigawatts, out of which 8.5 would be thermal. Sorry, we have a generating capacity of around 14 gigawatts, out of which 8.5 would be thermal, zero point 0.5 would be hydro. We have approximately 4 solar, and 1 would be wind. So essentially, you're seeing a 67 to 70% dominance by thermal in our current portfolio. What the vision of Tata Power for the next 5 years is, and this is in link linking with the renewable energy targets which you mentioned for India, that going into 2027 and by 2030, we would be not adding any thermal capacities in our portfolio, while at the same time, we will be concentrating only on renewables. So by 2027, we'll be adding 16 gigawatts to our 14 gigawatt existing capacity, which will be purely from renewables. And by 2045, we aim to be carbon neutral, which again is going to be achieved by humongous additions in our renewable assets, and at the same time retiring all our thermal plants as they reach their end of life. So that was from the point of view of the contribution in the renewable energy capacity. So we aspire to add at least 3 to 4 gigawatts year on year going forward. How are we going to do that? So we basically also have a module and a cell manufacturing facility. So in the year 1984, if I again go back in time, so in the year 1984, we had a company by name BP Solar, which we had acquired. So this was into PV cells and PV module manufacturing, totaling to zero point 0.5 gigawatt of cell manufacturing and zero point 0.5 gigawatt of module manufacturing. This was based in Bangalore. Currently, also it is uh, running. And to this, we are adding one more manufacturing facility, which is which is to the tune of 4 gigawatts. So 4 gigawatts of cell and module manufacturing facility are coming up. We are going to start operations of this facility by year end on the module side, and on the cell side, probably a few months in 2024. So this was basically the intention of or the output from these plants is going to be to support our growth ambitions in the renewable energy sector. Now, as you uh, as you know that renewable energy, especially solar PV, is seeing a massive shift in terms of technology development. So engineers and their expertise and their capabilities plays a very wide role in fulfilling these growth ambitions also. So historically, we have been using multicrystalline as the dominant technology for module generation, module production, and cell production. Now, multicrystalline kind of technology has been completely wiped out, and we are now looking at monocrystalline. So, our existing facility in Bangalore was a mix of multi, which we are now converting to mono, and our the facility which is coming up in Tamil Nadu is based on a new technology which is known as mono-PERC, and it is designed in a way, or it is you know being brought up in a way that if there is a new technology shift coming up, let's say if the technology of the future becomes TopCon, then we will be able to upgrade our facility without any upgradation required. I mean, it would be minimum upgradations. So that's the kind of engineering optimization which we have inculcated in going for these manufacturing facilities. So the engineers who are kind of live right now and hearing us, what we aspire or what we want is basically convergence with respect to the changing domain, be it efficiencies, be it technologies which help in improving the yield of existing assets. These could be the areas which we are looking for when it comes to engineering expertise. To give you an example, as I mentioned about efficiency, so right now, whatever commercial modules we see, they are in the range of 21 to 22%. There could be a technology, or there could be a shift in technology, or we could experience a risk wherein there could be a technology shift from where we are right now to a very high cell efficiency. Therefore, we need to be prepared, and we need to be on our guard in terms of guarding this risk or not allowing this risk to wipe out our business. So uh, maybe you can build on this.
No, absolutely. I totally understand that there's a lot of initiatives that have to take place congruently and parallelly to make this happen. Transitioning into what modernization would be required in existing grids, grid modernization is crucial as renewable energy integration grows. Could you provide insights into the engineering efforts at Tata Power to modernize the grid and ensure grid stability as renewable penetration increases, and how engineers could be a part of these initiatives?
Right. So again, some technicalities with respect to the grid needs to be understood to answer this question. So what we as a company pride on is providing reliable power and providing quality power. What do I mean by that? It basically means that at your home you will receive power 24 by 7 without any cut. So that is a meaning of reliable power. And uh, by quality of power, what we mean is that there is no voltage fluctuation, or there is no tripping happening because of voltage fluctuation. So to ensure that, there is a lot of back end work which goes on in trying to ensure that the grid remains stable, it doesn't trip, doesn't lead to any blackouts, it doesn't lead to power going off when uh, it should not be going off. I mean, we should ensure that. So from that perspective, renewables presents a challenge that renewables is basically dependent on energy which is available from solar or wind, right? These are the primary sources of energy generation. Now, let's say sun is available at a particular time, but there is a cloud coming in, and therefore it cuts off my generation. So what it brings about is a intermittent generation profile because of these factors. And wind start generating, or the turbine in the or the wind turbine start generating only when certain speeds are encountered. So if it goes below that speed, then the generation kind of gets cut off. So these are the intermittent nature of generation which we see when it comes to renewables. Therefore, in order to ensure a 24 by 7 supply, we need to fill these intermittent gaps through innovations. One of the aspects which we are looking at is providing a bundled solution. So, in order to maintain this stability, we fill in the gaps by providing energy storage devices, which basically ensures that whenever my demand is at certain level, but my supply is at a higher level, that delta is stored in the battery. And whenever there is a gap coming in, let's say renewable is kind of getting cut off, the battery kicks in and kinds of fills in the gaps. So this kind of a project we have done in our area of operation in Delhi. This is basically taking care of the aspect of uh, connection to the grid and ensuring that grid remains stable. So a pilot project known as iElectrics has been demonstrated, and people who are in Delhi wanting to get a feel of this particular project are more than welcome to connect with us. We'll be happy to showcase this.
Fantastic, fantastic. Speaking of renewable energy and solar and wind, Tata Power has also been a pioneer in rooftop solar installations. Can you share specific insights on the growth potential of the rooftop solar market and engineering opportunities that it offers for decentralized energy production, and how engineers could actually contribute to this sector within Tata Power?
Right. So when it comes to solar rooftop, uh, we have been a market leader. Uh, if you happen to see Brabant Stadium, let's say if the match is on and if they give you a glimpse of the roof, you will see modules on top of the roof, and that is something which Tata Power has kind of installed. So these are the uh, so we have basically done rooftop at higher levels, like at hundreds of kilowatts, and also for very small roofs catering to 5 kilowatts, 10 kilowatts, 15 kilowatts kind of a level. All these solutions which we are providing is basically possible because there is a lot of back end work which goes on in designing an optimum solution. So we have a system wherein sitting here we are able to locate the coordinates of the roof, uh, look at the dimensions which are available in the roof, and optimally place the modules in a way that it is visible to the potential user before it is actually getting installed in a virtual manner. So this is something which we offer to all our customers, that get a feel of how the roof would look like with the modules. And if you're okay with the placement and everything, we kind of go and install rooftop solutions. Now, as I mentioned that we are a market leader, and we have been a market leader in this for the past 5 years. When it comes to our market share, it is substantially higher compared to the competitors. Having said that, there is a risk that this market share kind of, or the differential between the first and second kind of goes down, or in the near future, because of disruption which are happening in this sector. So what we are, trying to understand is there is one area which is at the roof, which is exposed directly to the sun. But there are lots of facades which are available as potential opportunities for rooftop solutions. What I mean by that is there are technologies which are coming up which are not dependent on crystalline silicon kind of solutions. So there are flexible modules coming up. There are transparent modules coming up. So imagine you have a window which is able to generate electricity, but at the same time not compromise on the aesthetics part of it. If you're sitting inside, you're able to see what is outside, but at the same time, it is giving you some electricity. So these are the kind of solutions which are coming up in the market. And if engineers are kind of aware and capable of developing innovations around these applications, we could look at niche opportunities in the solar rooftop sector. So areas which ideally cannot be looked at from a crystalline silicon point of view could be explored and could be converted into a new business segment via these upcoming technologies. So how to do that, the engineering aspects of it, the techno commercials of it, all those knowledge base, if the engineers have, it would be helpful.
That's really great. So, from what I gather, is that actually from end to end, from actually manufacturing to actually placing these, and then also providing the customer an interface to be able to track this. There's several domains from engineering that actually come into play and would be able to contribute in this segment.
That's correct.
Right.
Yeah. So
Great. Going down another really attractive topic, and something that's been in the that's talk of the town is EVs, and we've heard so much, and there's been a lot of development in this last few years on that. And electric mobility is a significant part of the energy landscape. How is Tata Power involved in developing charging infrastructure and promoting EVs, and what engineering roles and projects are available in this domain, and how is it aligned with Tata Power's vision in this decade? If you could elaborate on that, I'm sure there's engineers who'd love to hear that as well.
right. So firstly, when it comes to the targets given by, let's say, Government of India, it basically says that by 2030, at least 30% penetration should happen with respect to electric vehicles. What it means is whatever vehicles you have, out of which, let's say, continue to run till 2030, 30% of that would be electric vehicles. Now, for that to happen, you also need to have a charging infrastructure in place. So we as a company have taken this approach that irrespective of whether EV penetration accelerates or it kind of remains steady in terms of growth, we will accelerate our efforts in terms of setting up charging stations across the country. So today, if you look at our portfolio, we are basically having more than 4,000 public chargers across the country, which is the largest infra anybody could have placed. So we pride ourselves in this aspect that we have taken this initiative of uh, as we talked about decarbonization goals. So this is in a way helping achieve that, because we are kind of influencing the user that there is a charging station available, if it is possible and if it is convenient for a particular customer, switch from a gasoline based vehicle to a electric vehicle, because charging station is available. Now we also have a app known as Tata Power Easy app, which anybody can kind of download on their mobile through the Play Store. This app basically gives you a feel of in your area, which is the nearest charging station, what is the status of that charging station, and let's say if you want to schedule your charging, how much time it would kind of possibly take, and the estimate, and so on and so forth. So at the convenience of the user, he can kind of schedule his charging by either going to a public charging station or charge it at the convenience of his or her home, because we also provide what is known as a home charging solution. So there are obviously different rates when it comes to home charging versus public charging, and the innovations which we have brought about is, with respect to home charging, it is a slow charging solution. So imagine this way, that you have a EV, you run it, let's say, for a few kilometers, going from your home to office and then coming back. As you come back, you have parked your car and you're not going to use the car. So overnight you can charge it. So a slow solution means it takes about 8 to 10 hours for it to kind of charge. And by morning it is kind of fully charged, and therefore you can use it for let's say another 100 to 120 odd kilometers before it requires charging again. depending upon which kind of EV you're driving. Now, when it comes to a public charging, it will definitely not be an 8 hour or a 10 hour kind of a charging session. It would be close to 1 hour, 2 hours kind of a charging session. So, how do we ensure that the user is not inconvenienced? Is place it in a mall. So, if you're going to a mall, you park your car, assuming that you spend around 1 to 2 hours, that is sufficient for it to get charged over there. Uh, so, this is one aspect of EV charging. The other aspect which we are kind of looking at it is that this charger could also be a source of energy. You know, imagine that there is a it requires basically grid connection, and for it to kind of continuously exhibit or provide power to a EV vehicle. Now, if grid is not available, then there are options of putting up a solar plant which generates during the day, and for and also has a battery system along with it. So the solar plant basically generates and the energy stored in the battery, and that battery is then utilized for charging the electric vehicle as and when the electric vehicle kind of arrives. Now, electric vehicle as such also is a source of energy, and therefore there are solutions which are kind of developing that EV user can be incentivized in terms of providing this energy back to the grid, or in the case where I mentioned solar is not there but battery needs charge, then the EV user can kind of help in charging the battery. There are incentives available in European markets in terms of allowing this kind of transaction to happen, wherein the EV user becomes a producer of electricity. This is known as vehicle to grid kind of a service. So these are some of the innovations which we are seeing in the EV charging you know domain. The other aspect is charging time. So how do we reduce the charging time? There are innovations which are happening in this aspect as well, wherein we are looking at I think 15 to 30 minutes charging time as the record as of now, which probably would reduce further as we go along. Now, what we are working on as a in terms of innovations or potential opportunities for engineers is looking at uh, how many charging sessions can we schedule per charging station in a day. Therefore, can we monetize our charger in a much more efficient manner? So right now it is at a certain level, but we obviously have scope for improvement as we go along in terms of since we have taken the decision of setting up charging stations irrespective of EV penetration happening the way it should happen. There are certain stations uh, which are giving higher revenue. There are certain stations which are at a lower level compared to the stations which are performing at a higher level. So from that perspective, these are the challenges for which innovations are required in terms of ensuring that place the charger at a location where the EV users are likely to come the most. That's one area which we are kind of exploring and working on. And there could be engineers who could have innovations or innovative solutions from that aspect. The second thing is, as point number two, which you mentioned about grid modernization. So every EV user, when he connects to the grid, will be borrowing energy from the grid, right? So is my grid capable of handling this 30% penetration, which we talked about by 2030? The answer could be yes or no. There needs to be studies and there needs to be detailed analysis about it. So this is what we are attempting right now for our Mumbai and Delhi areas where we have discoms. As engineers, there could be solutions to look at how do we ensure that we are able to predict the penetration of EV at a particular network, and at the same time my grid or my network is capable of dispensing that power without causing any tripping at some other location. So these are the challenges which we are trying to address through various solutions, and if engineers have skill sets in this domain, that would really help.
Fantastic. So, what I gather is that actually the growth of EV is also dependent on innovations in the back end, or specifically with grid modernization and charging stations. So we've what you said was you've reached a certain scale with these charging stations. Do you think that what does that look like in the next decade? Are we expecting EVs to really penetrate the automotive sector and really be on the roads? And the scale at which it enters, would Tata Power be able to cater to that market?
So I would say that we are slightly ahead of our times in terms of setting up charging stations. As I mentioned, that not every charging station we set up has the same monetization potential. So as a company, we have taken this stand that irrespective of EV penetration happening, at a certain rate which we aspire it to happen, we will set up the charging station so that the anxiety of the EV user, that if I have to plan a trip, whether there are going to be charging stations or not. So that kind of anxiety we are trying to eliminate. Uh, Now, to the question which you had, yes, policies are being framed in a way that it is encouraging EV penetration. There are favorable tariffs being provided by the government. There are favorable incentives to users to, let's say, if the EV is coming at, let's say, some X rupees, there are subsidies being provided by the government. Therefore, the price comes down by 10-20%, which is an incentive for the user to kind of switch. Ultimately, it's up to the user to decide when he wants to switch from an petrol-based vehicle or a diesel-based vehicle or a CNG-based vehicle to a EV-based vehicle. Uh, that's a personal choice. But to answer your question, we are seeing a lot of, I mean, if you look at the numbers from, let's say, our sister company, Tata Motors, the EV sales have gone up substantially when we compare last year to this year. So that itself is proof that EV penetration is exponentially rising and it is going to continue in the near future. Therefore, if EV penetration is rising, the backend work which we are doing right now with respect to grid or with respect to setting up of charging stations will definitely has to match the pace of EV penetration as well.
Right, right. That makes a lot of sense. Similarly, for solar panels and solar installations, in the last 5 years, we've seen that this has also entered the residential space in a massive way. So, how is Tata Power setting up to scale in that segment, or is Tata Power setting up to scale in that segment as well?
So, as I mentioned, that Tata Power has been, a leader in terms of solar rooftop. We have this position for the last 5 years and aspire to do that in the coming decade as well. And therefore, we need to be ahead of the competition. So, one of the solutions which I mentioned, that we give the user the experience of how the roof would look like with the panel, uh, the backend information with respect to ensuring that it is an optimum design, so the cost kind of goes down for the user compared to, let's say, XYZ player. uh, we also uh, uh, we also do a energy calculation for the user, that let's say right now if the user is paying X rupees, and if they switch to a solar rooftop kind of a solution, therefore, and whatever electricity consumption they have is completely taken care by the solar part. There is whatever investment they are making, they are able to get their investment back via savings made in, let's say, some X number of years. So this kind of education we provide to every user, basis which the user kind of decides whether they want to go for a rooftop solution or not. So this sensitization of the user uh, in terms of energy payback or financial payback, and at the same time guaranteeing that the solution will last for 25 years, is something which we pride upon and we offer to our residential customers.
Fantastic, fantastic. And I've also had a question around energy storage and energy storage being pivotal for renewable energy integration. So what is Tata Power doing to harness energy storage technologies, particularly batteries, in the Indian context, and how could engineers play a role in advancing energy storage solutions within Tata Power's operations?
Yeah, excellent question. So Tata Power per se is not energy, battery manufacturing company. We are basically users of batteries. So I will give you applications where Tata Power is using batteries right now. So imagine imagine a solution wherein the user basically wants green power, and the user wants green power 24 by 7. Now, if I look at my renewable component, it is essentially comprised of solar and wind, and to some extent hydro. Solar will be available during daytime, while wind might be available during day or night, depending upon how the wind is kind of blowing. So, and if I have hydro, the hydro resources are kind of limited, and only certain portion of the energy profile can be fulfilled by that. So I am still left with certain portion, let's say 10-20%, which if a grid is not available, the user is kind of using a diesel genset to uh, to augment that power. Now, this is where a battery can come in. Now, a battery can plug that gap, which right now a DG is kind of plugging, at the same time ensuring that green power is kind of provided. So battery basically requires energy from either solar or wind or hydro to charge it. And when these options are not available, but there is demand from the user, the battery kind of discharges it. So that gap filling is kind of done by the battery. Now, which battery to go into, because there are several battery types available. For example, conventionally, people would have been using lead acid batteries, which everybody might be aware is also there in your car. So if you open the car and see the battery pack which you see in your car would be a lead acid kind of a combination. Why lead acid is because it's the cheapest. So I am basically spending less in terms of energy compared to, let's say, other battery chemistries which are available in the market. Why? So while this has been the cheapest form, it also has the lowest life. So every 2000 or 2500 cycles of charging and discharging, I have to replace this battery in a particular application. That's the reason why you hear more of lithium ion batteries right now, which are being used in your EVs. So lithium ion batteries basically offers the advantage that compared to a 2000 cycle life for lead acid, I can get as high as 6000 to 7000 cycles from a lithium ion battery. So I am not looking at replacing the battery every 2-3 years, but I am looking at a battery replacement every 8 to 10 years.
Right.
So from that perspective, it offers me better economics. Lithium ion also offers characteristics like a quick discharge. So let's say I have to use a DG for 15 minutes and then shut off the DG. Thereafter, my conventional source of power will kick in, right? So lithium ion offers that flexibility of providing that discharge of certain energy in that 15-minute interval, while a lead acid battery or some other battery chemistry may not provide that flexibility. So lithium ion kind of fits the bill for fast discharge kind of applications, and also fits the bill for applications requiring longer life cycle. There are other battery chemistries which are available. For example, redox flow battery. There are new chemistries coming up. Let's say aluminum air, manganese. Uh, I, I'm kind of and some other battery chemistries also which are available, right?
Right.
When it comes to redox flow batteries, they basically are capable of discharging for longer durations. Therefore, if I have a 15-minute requirement, redox flow battery won't fit the bill. But if it is a 2-hour requirement, probably redox flow battery might fit the bill. So that's how the battery chemistry options are kind of divided across the value chain. Now, what Tata Power is doing is transitioning from a lead acid kind of a combination to a lithium ion kind of a combination in its applications. So, be it our offering for green power or what we call as renewable round the clock power offering, we integrate lithium ion with our solar and wind solutions, and depending upon the cost of power or whatever we are realizing, it could be a combination of solar, wind, hydro plus battery, or maybe solar, wind, hydro, the way it may be, the kind of portrait. Uh, in our existing uh, order book, we have a 120 megawatt battery energy storage system, which is coming up in Chhattisgarh, uh, probably by the end of the financial year. So that is one thing which we are doing. Second is uh, in areas where grid is not available, let's say off-grid areas or partially off-grid areas, we are providing microgrid kind of a solution. So microgrid essentially is a 30 kilowatt solar plus a battery, and which is basically providing power to villages where power is kind of not available. So this also requires a battery combination. Here, because the cost of power has to be kept low, we have as of now gone with lead acid, but we are very quickly transitioning from a lead acid kind of a combination to a lithium ion and a redox flow battery kind of a combination for the you know uh, d- d- depending upon what sort of economics we derive, we basically position a lithium ion or a vanadium flow battery or a lead acid kind of a combination. Then on the grid side, as I mentioned, there is this demand supply gap which has to be managed, because if demand is at a certain level and if the supply is kind of not matched, this causes frequency imbalance, and that can cause grid tripping. Now if there is a frequency imbalance happening, we are penalized for that as a utility operator. So to ensure that it doesn't happen, we have to make sure that our generation kind of matches the supply. So from that perspective, there are applications of energy storage, which is known as frequency response kind of an application, which requires very quick discharge. Let's say to the tune of some milliseconds or seconds. So here in another sort of a battery combination like a super cap or ultra cap might fit in. Now, uh, looking at the various applications we have, right now uh, we have presence with respect to lead acid and lithium ion kind of a combination. But going forward, as you can see that if you look at the supply chain of lithium ion, it is dependent on supply of lithium, right? And the reserves of lithium are kind of concentrated in certain areas, while the manufacturing of lithium cells is majorly concentrated in China. So we are basically, since we are not into cell manufacturing, majorly cell assembling into a battery pack, we as in India, I'm talking about, not Tata Power. So from that perspective, what we understand is that we are also exposed to the price shocks which might happen due to the probably less availability of lithium, etc., etc. So when these things are put into picture, right? As an engineer, what needs to come out is that how can we ensure that we are insulated from this shock, at the same time look at different battery chemistries, integrate them for these various applications at the lowest cost of power possible. So these solutions and the optimization, these are the opportunities for the engineers who are watching this show right now. That from an energy storage perspective, there are lots of innovations which are around the corner, and application of that within an ecosystem could be the point where engineers could come in.
Fantastic. Speaking of engineers and so much innovation and application, is there a general set of skills that you could think of right off the bat that would be useful at Tata Power or in the energy sector at large?
So one thing is for sure that anyone who aspires to come, let's say, in the energy sector in general and in Tata Power in particular, should have a know-how of the trends which are kind of evolving in the energy sector. So when I say that, what I mean by that is, if you look at our if you look at the evolution of PV, uh, 10 years ago, solar PV was at a certain price, and nobody had thought that it would, hit rock bottom in the next 5 to 6 years, 7 years. But it's a reality which has happened, and it continues to go down. The efficiencies kind of continue to improve or go up. So skill sets in this domain is a must uh, in terms of engineers coming in. Uh, there are also skill sets required in terms of understanding that uh, if we have to, like in the case of lithium, silicon is something which is again dominant from China. And if as a country we have to insulate ourselves from this, China dominance, which essentially has taken part twice in the last 10 years. So silicon supply, or for that matter, polysilicon supply, was dominated by USA by in 2010. When China entered the market, they basically brought the polysilicon prices to a level where US companies couldn't compete. So they wiped them out completely, and they have sustained the manufacturing of polysilicon in a way that today 80 to 90% of our requirements come from China. So they can easily bring the price of polysilicon up or bring the price of polysilicon down. What that means for us is, as a cell and module manufacturer, because we have to uh, constantly meet the low, you know, tariffs which are being realized in the solar energy sector, we cannot pass on these shocks which are experienced on the supply side to the consumer, because then we will not be able to compete in the business. So as engineers, what skill sets we require is basically try to address this problem in an innovative manner, such that the cells and modules manufacturers who are there in this country right now and who are, facing this burden as a whole, are able to insulate themselves from this shock. So looking at non-silicon kind of technologies, non-silicon kind of PV manufacturing capabilities, these could be areas where engineers and their skill sets which could help in realizing this potential. I also talked about new opportunities. So for example, uh, exploring rooftops in a way, rooftops or rooftop solutions in a way that I am not limited to the roof on the top, but I am also utilizing the buildings in a way that it is contributing to energy generation for the requirement of the building.
That's really helpful. So that gives a really good overview on around what kind of skill sets engineers would need. That pretty much wraps up our main discussion. So I'm going to jump into questions that attendees have for you. And the first one is, what is the role of environmental engineers in the energy sector? If you could share a few words on that.
Well, everyone is coming out with a statement saying that we will be carbon neutral by so and so year, we will be carbon neutral or maybe carbon negative by so and so year, right? So as an environmental engineer, the first step would be to kind of create a baseline for whichever company you end up into, that where is it right now in terms of its scope 1 emissions, scope 2 emissions, scope 3 emissions, right? If you look at our vision, we are an active participant in ESG compliance, and from that perspective, we are, ensuring that we try and meet our ESG targets. So, as an environmental engineer, you could look at opportunities in this sector, contribute in terms of giving a roadmap, creating a roadmap, and ensuring that the roadmap kind of gets delivered and executed in achieving excellence in our ESG targets, in achieving. Uh, so, we have a decarbonization target of 2045 as a as an opportunity. Can you bring it down to 2040? I mean, 5 years earlier, or maybe 4 years earlier, or maybe being more ambitious. So as an environmental engineer, you could create this opportunity for the company by giving your ideas or innovations or some solutions. So that could be your contribution.
Fantastic. I'm going on to the next question here, and we have somebody asking: is there a requirement for mechanical engineers in making grids?
Uh, To be very honest, I am not sure how I can answer that, because, to my understanding, mechanical engineers would require some sort of electrical expertise, in managing the grids. But I am a chemical engineer, and right now I am working in a electricity dominated sector. So, as an engineer, leave aside the fact that you're a mechanical or an electrical or a chemical engineer. As an engineer, basically you have this capability of adapting yourself to the domain and at the same time, curating solutions around it. So even if you're a mechanical engineer, you would have a basic understanding of the electricity sector, and from that perspective, you could contribute. Uh, One way to look at it is this way, that everybody has hands-on experience on computing. Everybody has hands-on experience on programming. So if you are capable of writing some codes, or if you are capable of you know studying the nitty-gritties of a particular aspect related to grid, you would be more than handful, be it mechanical, be it electrical, or be it chemical like myself.
Fantastic. Actually, that plays into the next question that I have. Somebody in a traditional electrical engineer route was wondering how could they switch to the EV sector, if you had any tips for them.
So when you say EV sector, it means I think you are addressing the fact that you want to look at electric vehicle manufacturing. If that is the case, then uh, not really sure how that would uh, go in. But having said that, uh, electric vehicle has a major component, that is the battery, and it has a circuit around it, which requires a lot of power electronics. So electrical engineers definitely has a role to play uh, in EVs and in electric vehicle manufacturing, especially in the battery pack assembly and in battery pack optimization, and ensuring that the performance of the battery meets the standards and meets the guidelines which are provided by BIS. So electrical engineers definitely have a role to play in the EV sector, but uh, they would have a major role to play in the electricity and the energy sector.
Right, right. That's absolutely true. With that, I think we have addressed all the questions that we have today. Thank you so much for your time. If you had any parting words of wisdom for all the engineers looking for jobs, let us know, and then we can wrap up our session today.
Right. I also do the job of inducting GETs within our company, and my job is also to, have sessions on innovation with them. So what I kind of tell them is, we are basically at a point where we are moving from a fossil-dominated energy industry to basically a decarbonized world, wherein lots of energy transitions are taking place. So as budding engineers, as a company, we have kind of survived for 100 years on certain domains of our business, be it hydro, thermal, uh, PV, wind. But as we are transitioning into the energy transition, which we are seeing right now, there are lots and lots of solutions which are coming up and which are likely to disrupt this power sector. Now, we could be wiped out. In spite of having this 100-year legacy, we could be wiped out in the near future if we are not adept, or if we don't keep up with the transition which is happening across the globe. So, as budding engineer, keep yourself abreast of these disruptions, of these innovations which are happening, and if you have those knowledge with you, it would help in your growth, because there are hundreds and thousands of opportunities available in the energy sector, in the power sector. And if you have even 1% to 2% of this knowledge wisdom available with you, you would be easily absorbed, because everybody is hungry for these kind of innovations, for them to sustain for the next 10, 20, 30, 40, 50 years. So this would be my advice to every budding engineer, is to keep reading, is to keep understanding the trends, and develop your skill sets. Don't limit yourself to a particular level of expertise, and you will grow.
Fantastic. Thank you so much for those words. With that, we'll wrap up our session. I think this was truly informative and insightful, and it gave us a worldview into what's actually happening in the energy and power sector. And thank you so much for your time today.
I hope my knowledge, which I have kind of shared, has helped in, you know, improving the knowledge base, and at the same time inspire engineers to apply in the energy sector and power sector. Thank you.
Absolutely. Thank you so much.
Thank you.